All right, 3.6 is going to finish up chapter 3 for us. And it's going to bring together some of the different topics that we've seen before in the chapter. One of the topics we've seen before in the chapter is this idea of truth tables. They were one of your favorites. They really weren't that bad, right? They really aren't. They're not that bad. They have a very straightforward form. In some cases, they're a little bit more descriptive than others. And remind me before we get done, I have homework, I believe, to hand back to you, right? Okay, so let's make sure we do that too. Did I hand it back last time? Or am I imagining that? Okay, I think I have homework to hand back to you. I'll check. And then we also talked about then in 3.5, Euler diagrams. And the Euler diagrams were for the purpose of analyzing arguments. Okay? So 3.6 is going to bring back the truth table idea in, and one other idea too, into the idea of analyzing arguments. All right, so for starters, we're going to be testing the validity. Oops, sorry about that. Testing the validity of an argument with a truth table, and there are several steps. So we're going to do a little bit of writing for me while I do this. So step 1 is to assign a letter to represent each component statement in an argument. Okay, so we're going to turn our arguments into symbols, basically. And by doing that, we need steps 1 and 2. Step 1 is to figure out what you want your component statement's letters to be. P, Q, and R, and S, and T, and those are the kinds of letters we've seen mostly. Second statement, or second step, is to express the premise and conclusion symbolically. In other words, you may have a P arrow Q. You may have an and statement or an or statement with those symbols. So you're going to combine all those pieces into symbols, turn them into symbols. Can I go to step 3? Okay. Okay, steps 3 and 4. Oh, sorry, Leah. Let me move it back.
Okay.
All right, steps 3 and 4, a little bit more detailed. And when we do them, they won't seem as wordy as they are as you're writing them. Step 3 is we're going to form the symbolic statement of the entire argument by writing the conjunction of all the premises as the antecedent of a conditional statement and the conclusion as the consequence. It sounds impressive, doesn't it? It won't look near as impressive when we do it, okay? All right, so the picture you should have in your mind is we're going to have arguments that look somewhat similar to what we did in the last section. You've got a sentence, you've got a sentence, you've got a line, and then you've got a conclusion sentence. Okay? So you're going to write some symbols for the first one, you're going to write some symbols for the second one, you're going to write some symbols for the conclusion statement. Okay, that was what steps 1 and 2 said you were going to do. Step 3 says you're going to take the first statement and the second statement, and you're going to put them next to each other with an and symbol between them. Okay? And then you're going to put all that together and put an arrow for the last statement. And the last statement is the conclusion statement or the consequent. That's what step 3 says you're going to do here. You're going to write the symbols all out in one really long statement. And then step 4 says you're going to do a truth table for all of it. And you're going to look at the final column of your truth table. And if the final column says all T's, what do we call that in the last section? A tautology. So if the final column is a tautology, then the argument is valid. If there's any false statement in that last line of your truth table, that last column of your truth table, then the argument is invalid. This one has a lot of writing. You ready to try one?
Not yet.
Not yet.
I'm not done mine all this.
Okay. Okay, what we're going to do is we're going to go out of order, I think. Let's start with number 2. I know, this seems crazy. Number 2 actually has step 1, it's all in symbols. Step 2, I've got these arrows in it. And step 3, it's all written as one long line, already done. All we would have to do for this particular problem, and you're going to have one in your homework like this and some on my math lab, is to do the truth table. But it looks really messy, doesn't it? And this is where this whole idea of making our column headers into numbers, which I've shown you once before, is going to come in handy. Because at some point here, and I think it's going to be on example 3, if you write out all the column headers, you may run out of space across the top of your page. That's exciting, isn't it? What a big truth table we're talking about. So let's take a look at this. First of all, ask you a question. How many different statements do we have? Individual letter statements. 3. So how many rows will there be in my truth table?
8.
8. All right, so let's start with that. Start with the table. And where do I start? What letters are going to go in first? P, Q, and R. All right. All right, after my P, Q, and R, what else do I need? Am I need tildes on this one?
No tildes.
No tildes, that's kind of nice, right? Okay, now you see lots of parentheses, don't you? And I need a column for each one of those parentheses. Which one would you like to start with? First one, P arrow Q, sounds like a good place to start. All right, then what? The second one, Q arrow R.
Then P arrow R.
And I'm actually going to hold off on the P arrow R for a minute. Let's do that in a minute. Let's actually start with the inside because we've done the inside of the brackets so far. We did the P arrow Q and the Q arrow R. Let's put all of that together. And let's do this so that I don't have to write it all by calling these numbers. And I should have started this a little bit lower. I'll use yellow and write on top of things. So this is number 1 and number 2. What am I going to do with columns 1 and 2? Combine them with the and statement. I'm working inside the first bracket. Is everybody with me? So I've got 1 and 2 that I'm going to combine together. And that will do everything inside of the bracket before I hit that arrow, won't it? Okay. That's the premise that I've created, everything all combined. Then let me do that last arrow statement, P arrow R, that you had mentioned before. And I'm going to call this number 3. I need one more column, and what should it say? What should it say? It should have all of it, right? Yeah. And if you want, we could call the 1 and 2 something else, but it's not too bad. So I'm going to go here and write 1 and 2, which was a column I had before, arrow 3. Are we good on the column headers? Sure, right? All right, what goes inside of column P? All right, so 4 trues and then 4 falses. What about in column Q? True, true, false, false. And then same thing again, right? True, true, false, false. What about column R? Okay, this is one that alternates true, false, true, false, true, false, true, false. All right, we've got our first implication. We got lots of implications on this one, those arrow statements. So let's remind ourselves, since it's been a couple days, almost a week actually, since we've done truth tables, right? Because we didn't do them on Tuesday. When is an implication, a conditional, an if-then statement, true?
Every time except when it's true, implies false.
True implies false. That's exactly right. So if I have true implies false, that's false. Otherwise, the statement is true. So this one starts out, this is P implies Q. So this one's true, true, and a true, true. So both of those first two rows are true. The second two, they also match. They both start out true and end up false. That's the one and only time we have falses, right? Yep. So the third one and the fourth one, third and fourth row are both false. The last four rows all start out false, which means the result is true. All right. Let's take a look at the next ones. We've got Q and we've got R. We've got our second two columns. It's another implication, Q arrow R. So the first one's true implies true, which is true. The second one is true implies false, which is false. The third one is false implies true. And then the fourth one is false implies false, which is true. So both of those, row 3 and row 4, are both true. All right, row 5, true implies true is true. Row 6, true implies false is false. Row 7 and row 8 both start out false, so their result is true. Now, mostly I'm hearing choruses of people who are saying the right things. If that's not you and you're struggling, you need to come see me. Because if you can't do truth tables, you're going to be really stuck on the test, because there are going to be several of them on there. Okay? Please come see me. All right, next thing is not an implication. What do you see? 1 and 2. You've got an and statement, right? When is an and statement true? When they are both true. So if you have any false, then the statement is false. All right. So the ones that we're looking at are the rows that we just created, here and here. So on these two rows, these two columns. First row I have true, true, which is true. Second row I have true, false. Third row, false, true. Fourth row, false, true. Okay, everybody good so far? All right, fifth row, true, true. Sixth row, true, false. Seventh row, true, true. And eighth row, true, true. Perfect. All right, we've got one more arrow statement to do. Let's see what I can do on colors. P implies R. All right, those bluishy ones I just did. Okay, arrow statements, just like we did a minute ago. I've got true implies true. That's true. Second one is true implies false. It's false. Third row is true implies true. True. Fourth row is true implies false. Fifth row, sixth row, seventh row, and eighth row all start out false, which means they're all true.
And I found the tautology on this.
Well, we're not done. You may be done, but I am not done yet on my screen. So let's wait for just a second, okay? Last column in my table, right? My last column, I'm supposed to take the 1 and 2 that I just created a moment ago, 3 which I've created right here, and what am I supposed to do with them? Another arrow, right? The if-then statement. All right, so we're ready for our last one. We're looking to see if we have a tautology. First one, true implies true. True. Second one, false implies false. Third one, false implies true. And then false implies false. Okay, so we've got 4 trues so far. Fifth row, true implies true. Sixth row, false implies true. Seventh and eighth are both true implies trues. True. And so what do you see? A tautology. And a tautology means then that the argument is valid. So it's perfectly fine if you want to write down that it's a tautology, but the answer to the question is actually that it is valid, just like last section. Big truth tables, right? And that's how they're all going to feel in this section. Okay? Aren't you excited? I can tell. Okay, let's take a look at this one then. The nice thing about this one is what? It's smaller. Well, how do you know it's smaller? Because it looks smaller. Not quite. There's something else. There's only 2 letters, aren't there? That's right, Montana. So I only have a P and a Q. Hey, that's big in truth tables, right? Because what does that mean? 4 rows, not 8. All right, but the thing I don't have on this one is I don't have the statement all pushed together, correct? So I actually have to create that. So how do I do that? Well, I create that by taking the first statement, whoops, and put it in parentheses. And I join that with an and with the second statement. I'll put all of that in brackets and an arrow, and I create the last statement after that arrow. Okay? Statement 1 and statement 2, all in brackets, arrow, statement 3.
Will it always be an arrow between statements?
Always. Yes, it will. Always. All right, so let's do a truth table. We've already established a couple of features of the table. One of them is that there's only a P and a Q, which means I only have 2 component statements or 4 rows. So P and Q. What else do I need?
Tilde P.
I need a tilde P. What else do I need?
Tilde Q.
Tilde Q, right?
Is it okay to, like, on tests and stuff, to do it out of order from what you usually do?
You can. You need the P and the Q in the right spots to start with, but you could change the order after that. That would be fine. For instance, you might not want to do tilde Q right here.
That's not bad.
You might want to wait and do it toward the end because it's actually the last statement, and that would be very reasonable on this one. So it's up to you. Yeah. All right. So I've already got it written, so I'm going to leave it in this time. But what could I do next? Well, let's make all the column headers first, and then we'll come back to that. So what would be my next column header? Tilde P implies Q. So the first kind of set of parentheses here, right? Okay, after that, what could I do? Can I give it a number? So I don't have to write it again. Is that all right with you? Call this number 1. What am I going to do with that number 1 then? 1 and P, which gives me everything inside of that bracket, right? Then what? Right, so 1 and P implies tilde Q, and I've actually got all those pieces on my table, so this is my last one, isn't it? So 1 and P implies tilde Q. Those are all my column headers. This is actually smaller than the last one, but we had to put it all together, which was one extra step at the beginning. All right, so Holly, you wanted to tell me what goes underneath P. What goes underneath P?
True, true, and false.
It does. What goes under Q?
True, false. Wait, yeah. Okay.
Mm-hmm. You're right. All right, so somebody else tell me what tilde Q and tilde P are, but not in that order. Tilde P first. Okay, good. False, false. True, true. And then tilde Q? False, true, false, true. All right, everybody good with those columns? Okay. The next column is the first arrow column that I have, right? I need to take tilde P, and unfortunately I have to go backwards to tilde Q, or to Q rather, right? So in my mind I'm thinking this, right? So I've got to go backwards on my table, or in my mind I'm going to start with false. This is false implies true, which is true. The next one is false implies false, which is true. The third one is true implies true, which is true. And then the fourth one is true implies false, which is false. Well done. All right, so now let's take this column that we just created, number 1, and P. So in green here, this is an and statement, right? So don't get in your mind thinking we're doing an arrow here. We're not. This is and. So on the first row, I have true and true, which is true. On the second row, I have true and true, which is true. On the third and fourth row, I've got falses in the P column. What's that tell you? It's false, because an and statement can't have any false pieces, right? So these are going to be false. All right, so here is where I think it might have been handy for us to have not done the tilde Q earlier, right? But we did, so it's okay. I'm going to take this column that we just created and column tilde Q, and we're going to go, again, backwards here. Oh, it's not. Okay, let's give it just a sec. All right, so we're going to take the two columns that are in pink kind of now, and we're going to go backwards. Implication statement, right? So this first one here starts out true to false, which is false. The second one, true to true, is true. The third one, false and false on the third and fourth row. So those are both true. So what do you have? An invalid argument. This is not a tautology, so this is invalid. All right. We have one more, and for those of you who've printed out this already, what do you see? Words. You do. And not only are there words, but they don't even have a line like the last section do they? It's just like written in a big old paragraph, okay? So let's kind of give ourselves a little bit of structure by underlining the pieces of information we have. The first piece of information is the first sentence, and it's right here. All that really long sentence, and it's fabulous, isn't it?
It's like a Justin Bieber song.
It is, yeah. If I were a woman and you were my man, then I'd never stop loving you. This is not even a short sentence. This is a long one. All right, so that's sentence number one. So if we were looking back in that analyzing section in 3.5, that would have been the first line of that statement, right? Line number 2 says, I've stopped loving you. Whoops, let's try it again. I've stopped loving you. And now, at the very least, you have to appreciate that that's a short statement. Probably not going to involve a lot of symbols, right? Good for us. Third line, however, so the therefore means the line comes in here, right? So back from the last section, you actually see a line now with a result underneath it. The resulting statement then says, therefore, I am not a woman, and it should say, I am not your woman. There is a typo there. Not a, but your. I am not your woman, or you are not my man. Okay? So, what do we need to do first? I need some symbols, don't I? And it will...
symbolize woman?
So what do you want to symbolize woman? P? Okay. So the I were, and this again should say your woman. I need the word your in everything. All right. So this is P. I were your woman, or I am your woman. This is the P description. What else?
You were my man.
Right. The you were my man, that's Q. Then what? R is going to be about the loving situation, right? Whether they're loved or not. Okay. So I never stop loving you. You can actually make a decision on this. You can make R the statement positively, I've stopped loving you, or negatively, I've never stopped loving you. I don't care what it is. I'm going to make it just like it is and call it R, so that I don't have any extra tildes at the beginning of the statement. Okay? All right. How much space did I give myself? Oh, good. I got lots of space. All right. So let's create the first statement. The first statement says, if I were your woman and you were my man. What is that statement going to tell me I do? P and Q. And not only that, but there's an if before it, isn't there? Which means these two pieces have a line after them. Then what? Then R. I'd never stop loving you. Love you forever. Like you for always. No, that's a different book. Okay. Second statement says, I've stopped loving you. What's that mean? That's tilde R. That's right, Brandon. So I've got tilde R down here. Therefore, that's this line, right? This line that I had in the last section. It says, therefore, I am not your woman or you are not my man. What is that going to do for us? Tilde P, and then what? Or, so that's the V one, and then tilde Q. Okay, everybody with me on how those symbols were set up? Please, don't try to shortcut setting the symbols up. You're just going to mess it all up and you're not going to be able to even do the table next. All right? All right, here's what we do next then. I need to take each of these pieces and join them in that really long sentence like I had on problem number 2 where we began this mess, right? All right, so I need the first statement, P and Q, combined, arrow R. Then what? And, right, tilde R. And if it helps you, you can put this in brackets and then we can do another curly braces around this just to have more and more and more braces because that's good. Now what? The conclusion. What comes before the conclusion? An arrow. So I need an arrow, and then I need the conclusion statement. The tilde P or tilde Q statement. I may run out of screen space. So I'm going to try and write the smallest I can, and we'll see what happens on the next slide. But I need column headers. And what are my column headers going to start out being? P, Q, and R, which means this is a big truth table, right? P, Q, and R. And while I do have, I'm going to do what you guys suggested before. Let's wait and do the tildes at the end because I don't need them until the end. Is that good? All right. So I've got P, Q, and R. What else do I have next? P and Q, right? Start on the innermost parenthesis at the very beginning. Let's do P and Q.
I'm one step ahead, aren't I?
All right. What's going to be after P and Q? Right, so we're sort of in the middle and we're working our way outwards, right? Okay, so I've got, let me call the P and Q number 1. I'm going to have number 1 arrow R. Okay, now I've got everything inside the brackets. Now what? I need a tilde R, don't I? Because I didn't do any tildes yet. So let's do tilde R next because I now need it. So I kind of avoided doing it until I had to have it, but now I have to have it, so I need it, and we'll just write it in.
Is number 1 supposed to be implied or and, or is it the same thing?
I'm sorry, what was your question?
Is number 1 supposed to be implied, like on the truth table? Number 1, like is it supposed to be P and Q or P implied Q?
Oh, did I write something wrong? I did write something wrong. It was an and, wasn't it? Thank you. Let me fix it. Good catch. Does it look okay now?
Yeah.
Okay, thank you. Okay, so what did I need after this now? Yeah, can I call this number 2? Would that be okay? All right, so now I'm going to go 2 implies tilde R, because that was the part that's now inside a curly, no, not implies, is it? I keep wanting to put arrows. How about and tilde R? So worried about losing my space here, and I'm going to. Now what? I need a tilde P and I need a tilde Q, and I'm totally out of space. Let's try this. No, that's not going to work. Okay, let's just see what we can cram in here. I need a tilde P, I need a tilde Q, and then what do I need?
Or no, tilde P or
Yep, I do. So I need tilde P or tilde Q. You guys have got lots of space. I'm really trying. We just may have to say what that last one is without me writing it. I'll write it on the board. You guys can write it in on your notes. What's my last column going to be? All of it put together. Final result, right? Don't write down final result. Let's see what it says. The final result says I should take everything that I had in curly braces, which I already had a column for that, didn't I? Was that this yellow column that says 2 and tilde r? All right, well, let's call that 3. And then what? Okay. Can I call that 4? Will that work? So what could my last column header say? 3 arrow 4. So I don't have space even to write 3 arrow 4, but man, it's close. All right, that's what the last one should say, 3 arrow 4. Oh man, I'm so close too. 3 arrow. There's this button on the side of my screen that keeps changing places on my screen. So I can't write a 4. Like it looks like there's space, but it won't work. Okay, so pretend. Can you pretend for me that it says 3 for arrow 4? Okay, can we fill in the table? I'm tired already filling in this table and we haven't started. Okay, what's going to go column P? All right, 4 trues, 4 falses. How about column Q?
True, false,
Do we think we can fill in the first 3 columns of a truth table? Like under any circumstances, should we be able to do that? Okay, just making sure we've done it enough that we're okay with that. All right, so true, false on the last one, right? Okay, good. All right, the next one where we actually have to do something is an and statement. And it's doing P and Q. So the first 2 columns, and an and statement is true when? When they're both true. And they're both true on these columns in rows 1 and 2, right? Row 1 and row 2, they're both true. Everything else has a false statement in one location or the other. So column 1, that I've called column 1 now here with the 1 above it, is true, and then everything else is false. Are we good with that? Sometimes when you guys don't say anything, I feel like I should be like the preacher and say, speak now or forever hold your peace. Okay, so the next one actually is an arrow statement, right? And it wants us to actually go backwards. I'm going to take the column that I just created and go backwards to the column immediately before it, to column R. All right, so an arrow statement, the first one I've got is T implies T, which is true. And then I have true implies false, which is false implies true. False implies false. That one's true, still true. In fact, all of the last ones start out false, don't they? So all of these last 4 are also going to be true statements. I think if we count, we're halfway done. All right, tilde R. How do I do tilde R? Opposite of R. So what will tilde R say?
false, true.
And so on. That's right, false, true, and so on. Lined paper is a fabulous invention for these things, right? If you have it, use it. All right, number 3 then. Column 3 says that I need to take column 2 and column R, tilde R, which is the 2 columns that I just did previously, and I'm going to join them with an and statement. And when is an and statement true? When they're both true. So what do we see? First row is true, false, which is, second row is false, true, which is, third row is true, false, which is, fourth row is true, true. Hey, that one's true. Fifth row, true, false. Sixth row, true, true. Seventh row, true, false. And eighth row, true, true. Excellent. Oh, the next 2 columns, we can do those in our sleep nearly, right? Oh, don't really fall asleep, Leah. I didn't really mean to fall asleep. Okay, so tilde P then. Somebody tell me what tilde P is.
4 false, 4 true.
Right, 4 falses, 4 trues. Tilde Q.
One false, true, etc.
Lovely. Column 4 then takes those two columns we just created, joins them with an or statement. We haven't done an or statement today. When is an or statement true? At least one is true. So either one or both are true. Okay, so another way to ask it is, when is it not true? When is it false? If they're both false. All right, so these two columns that we just did right here, we're going to take a look at them. I have false, false is, and that's both first row and second row. They both start false, false. Then I've got false, true is, false, true is, true, false is, true, false is, and true, true is, and again, true. Lovely. And then I've got the column that has no header, but we know it's supposed to say 3 arrow 4, right? At least in theory we know that. All right, so we're going to take column 3 in green. We're going to take our last column, column 4, and we're going to do an arrow between them. So the first 3 in column 3 start out false, which means the result is true. The next one is true implies true, which is true. And then I have false implies true, true. And then I have true implies true. False implies true. And lastly, true implies true. And so what does this mean? This is a valid argument. Okay, awkward and funny as it sounded, it was actually valid. Okay. After all that hard work, are you ready for something that's just a little bit less hard? Okay. All right, so the part about this that you may not like is it's got a lot of language you may not have seen before. But please remember, you've got a note card, and you can write stuff on it, right? This is yes. Okay. All right, so what we're going to do is we're going to look at some valid argument forms, and then we're going to take statements and put them into the forms and see if they match. And if they match, they're valid. And if they match something else, they'll be invalid. This is a matching activity, you know, like memory when you were a kid? Okay, same kind of thing. All right, so modus ponens is one of our valid argument forms. And what it shows is it shows that if you have P implies Q as one of your statements, and your second statement is P, then the result is Q. So this is the statements that I was talking about at one point in class where I said, if I'm a mom, then I'm a woman. And the person walks in and they say, I'm a mom. Or I tell you the person out in the hall is a mom. Then you know for sure that the next result is they're a woman. Okay, that's modus ponens. Modus tollens is P arrow Q and then tilde Q. And we've got a line, tilde P. So let's use the same argument that I just did. If I'm a mom, then I'm a woman. Okay? And then I tell you this person out in the hall is not a woman, then you know for sure they are not a mom. Okay? Opposite of the first statement. Disjunctive syllogism says that if we have P or Q, and then we know tilde Q, in other words, we know P or Q, one of the two things are true. And we're told the first one's not. What does that mean? The second one is. The second one is. If one or the other of them is true and we're told one piece isn't, then the other one must be true. Make sense? Okay, think about your truth table. It's following that same idea. And then this last one is reasoning by transitivity. It says P arrow Q, Q arrow R, implies P arrow R. Okay, you've seen this done with numbers before. If 1 is less than 2 and 2 is less than 3, then 1 is less than 3. Right? I mean, you're just stringing things together. If A equals B and B equals C, then A equals C. Okay, this is reasoning by transitivity. You've done it before. There are two fallacies. Fallacies are forms that are invalid. They're false. They don't work. Okay? And they look uncannily similar to the ones you had before, but there are differences to them, obviously. I've got P arrow Q. I've got a Q and a line, and I've got P. So again, let's use my mom example. So if I'm a mom, then I'm a woman, and I tell you the person out in the hall is a woman, do you know for sure they're a mom? No, you don't. And that's a fallacy if you were to say that that were true. Okay? You're being correct. Fallacy of the inverse says P arrow Q, tilde P, therefore tilde Q. And it's the same thing. If I'm a mom, then I'm a woman, and I say, the person out in the hall is not a mom, do you know for sure they are not a woman? No. It still could be either on that one. So the tilde Q on that would not necessarily be true. Okay? So here's the cool thing about knowing these. We can take... Do you have a question, Leah?
Sorry, I'm just taking the notes here.
Oh, did I move it too fast?
Yeah.
Okay, let me stop then.
And can you go back to the...
One before?
Mhm.
Sure. All right, so these are going to, when we move on to 4 and 5, they're going to have very much the same kind of form that we saw in those Euler diagram ones in the last section. They're going to have the form where we've got two statements, we've got a line, and then we've got a concluding statement, and we're going to turn them into symbols, all right, which we didn't have to do with the Euler diagrams, but we're going to do them. Our goal is to get them to look like one of these 6 forms. Whichever 6 forms it matches up to will tell us whether it's valid or invalid. Make sense? Okay, we're going to do one about baseball. Well, maybe. Somebody didn't hold their breath long. Okay, let's try again. All right, one about baseball. It says, if Kerry Woods pitches, the Cubs win. The Cubs do not win, therefore Kerry Woods does not pitch. Okay, so our goal is to create P's and Q's and R's, whatever is necessary with these statements. You don't necessarily have to write down P is this, Q is this. You can kind of do it like we did one we did about the you are my woman and I am your man. Colt, can you put that away for me, please? Thank you. So what could we do with the first sentence? It says, if Kerry Woods pitches, the Cubs win. He implies Q sounds good to me too. I'm going to use a different color. So the first one would be P implies Q. Second one says the Cubs do not win. That's tilde Q, because the way that we've structured the first one, the issue about the Cubs winning was what we called Q, right? And then the second sentence says that doesn't happen. They don't win. So the last sentence then says Kerry Woods does not pitch. That's tilde P. So your goal now is to look back at those 6 forms and figure out which one of those 6 it was. So I'm not going to flip back on mine because you guys wrote them all down. Which one was it? Which one does it match? Really loud. Modus tollens, right? Does it? That's the one it matched? So the directions here says decide if the argument is valid or fallacy, valid or invalid. And then it says give the form that applies. You have to do 2 things. You have to decide if it's valid or a fallacy. Which one is this? It is valid. And then you have to claim why you know it's valid based on one of those forms. And the form that it matches is modus tollens. So this is valid by modus tollens.
I have a question.
Yeah.
I don't understand why it's valid, because it doesn't say they only win if Kerry Woods pitches.
No, but they say that if he does, they win. So if you know they lost, he couldn't have been pitching. Because if he had been pitching, what would have happened?
Oh, okay.
Right. We have one more. And the last one is a tribute to my mother-in-law. She's a wonderful woman. She's kind of a shoe person. All right. If she buys another pair of shoes, her closet will overflow. Her closet will overflow, or did overflow, or does overflow. Whatever verb you want to use there would be okay. And the result was she buys or bought another pair of shoes. Right? So, first sentence, if she buys another pair of shoes, her closet will overflow. What does that tell you could write? P implies Q. What does the next statement tell you you're going to write? Q. And the last statement, P. So go back and look. Which one is this? Fallacy of the converse. So is it valid or invalid? It's invalid. So you can write invalid or fallacy. So I'm going to write invalid. But if you write fallacy, it's the same thing. This is invalid by fallacy of the converse.